All right, so continuing on with these graphs, I want to spend a little bit extra time on it as well. But here we have v versus t graphs. And remember, the slope of a velocity versus time graph gives us the acceleration. I'm going to tell you something else about this in just a minute. But anyway, so here, for example, I have the acceleration. I have a positive acceleration. The acceleration is constant, that is, it doesn't change. Constant positive acceleration. That also means that the velocity is increasing. And I can see that because here the velocity is low and here the velocity is big. And also the velocity is positive, which I can see because the line here is in the first quadrant of the Cartesian coordinate system, which gives me a positive velocity. That is, this is the plus v axis. Here, likewise, on the second one, I have a positive velocity. Velocity is constant. Doesn't change, it's always this value. And also, acceleration is constant, and particular acceleration is equal to 0, because this plot has 0 slope. Now here I have a two-part thing. Here I have acceleration equal to 0, and here I have a negative acceleration. It's negative. The velocity, however, is positive. So that means that the velocity is decreasing, which you can see here as it goes from here to here, the magnitude of that velocity decreases. Let's just take a little aside and spend a little bit more time on graphing motion. Now remember, we have two different kinds of plots. We have displacement versus time, x versus t. Displacement versus time, the slope gives the velocity. All right, and then we also have v versus t. And in this case, the slope gives the acceleration. However, with velocity versus time, and I think I might have already mentioned this, but with velocity versus time, there's an additional thing that we can do. And that is that, let's say that I have a graph that looks like this. The area under this graph, say from here to here, gives me the distance covered. So the area under a v versus t graph gives the distance. If you ever forget which is which, just think about the units for these. So remember, slope is rise over run. This is in meters. This is in seconds. Rise over run is meters over seconds, which is the same as velocity. Similarly here, this is meters per second. This is seconds. So rise over run gives me meters per second, or meters per second squared. Right, so the slope of a v versus t graph gives me my acceleration, and the area gives the distance. Now, area is going to be the y-axis times the x-axis to get the area of that line, or the area under that graph. And if you look at the units of that, that's going to be meters per second times seconds, and those units will cancel out, which will give us meters, which are the units of x. So let's just look at a couple more examples, just sort of to jog your memory. And on the online quizzes, you'll see some examples of this, and on the old exams, you'll see some examples of this. You should expect to see several of these on the exam and on the quizzes. So let's say I have an x versus t graph like this. Let's say it's like that. I want you to characterize the velocity and the acceleration. Is the velocity positive or negative? Is it increasing or decreasing? Is the acceleration positive or negative? So first, is the velocity increasing or decreasing? And in particular, I want to know, is it speeding up or is it not speeding up? So instead of velocity, I'm going to say, is the speed increasing or decreasing? And I want to look at the slope. So here I have a basically zero slope, and here I have a steeper slope. So that means that this object is speeding up. It's going faster. All right. It has the sign of this slope is a negative slope. Negative slope. So that means that the velocity is negative. All right, so I have a velocity that's negative and it's speeding up. So if I were to plot the v versus t graph for this, I would have it start in the fourth quadrant. Actually, I'd have it start right here, because initially my velocity is 0. And it has a negative velocity. That means it's never going to enter the first quadrant. It's always going to be in the fourth quadrant. And it's going to speed up. So it's going to look like this. My v versus t graph will look like this. Notice here I have a 0 velocity. The object speeds up. So here it has 0. Let's say it has negative 10 meters per second down here. So it's speeding up. And so it also has a negative acceleration. I know it has a negative acceleration because it's speeding up in the negative direction. And so the acceleration has to be negative because the velocity and the acceleration have to be in the same direction. Or I can also look at the v versus t graph that I've created here for this scenario, and I see that it has a negative slope. Let's do one more, and don't worry if you're not getting this right now. You'll see it again on the online quizzes, and then also, as I said, in the homework and on the old exams, all to prepare you for the hour exam. Let's do one like this. It's going to be x versus t. It's going to look like that. I want to know, is the velocity positive or negative, first of all. Or actually, let's say, is the velocity increasing or decreasing? That is it speeding up or slowing down? And I'm going to take here, look, I have a 0 slope there. The slope gradually gets bigger and bigger. So I would say then that this object is speeding up. It's going faster. Is it speeding up in the positive or negative direction? That is the velocity positive or negative? Well, clearly this has a positive slope, so it has a positive velocity. All right, because the slope of these lines are positive. Now, if I were to create the v versus t graph, it would look like this. I'm starting at 0, and I'm increasing in speed in the positive direction. So it's going to look like that. Now the slope of this is positive, so it has a positive acceleration. All right, but you should see that since it's speeding up in the positive direction, from those two pieces of information, you should also be able to deduce that it has a positive acceleration. Let's see, let's just do one more. There aren't really that many iterations of this, so I'm not suggesting that you memorize them, but let's see. Let's do one like this. All right, this is x versus t, position versus time. I want to know, is it positive or negative velocity, and is it speeding up or slowing down? Well, here I have a big velocity, and it gets smaller and smaller, so it's slowing down. It is a positive velocity because it has a positive slope. And so if I were to look at these, would it have a positive or negative acceleration? Well, it's going, say, up, and it's slowing down. All right, so the acceleration is going to be opposite the velocity, so it's going to be a negative acceleration. And if I plot the v versus t, I'll see that initially has a big velocity, and that velocity slowly goes to 0. All right, so that's my velocity versus time. This point is represented here, and this point is represented here. That has a negative slope, so a negative acceleration. These are fairly important that you be able to understand and interpret these position and velocity versus time graphs. Also, let me remind you too, I've already said this, but and I think you see this in the homework and in the old exams, but also if I want to know the distance traveled, I've already said, I can just take the area under this graph, calculate the area under that graph. You know, in that way you you break it up into two pieces. This is a rectangle. This is a triangle. And you can do length times width, 1/2 base times height to find that area. You'll see some practice on that in the homework and in the old exams. But please be prepared to be able to do that.